In this video, you will learn how to create your own fully functional AI chatbot from scratch. Whether it's for personal use, your company use, or even your business, you will just learn how to build it yourself from scratch. The best part is that you won't even spend a single penny thanks to availability of open source models like Meta Llama, LLAMA 2, and LLAMA 3. These models provide cost-effective solutions for building a fully functional and production-ready chatbot. So without further ado, let's dive right into this tutorial and create our very own unique chatbot from scratch. Ready to do it? Let's get right into it. Are you looking for very affordable and easy to understand courses to learn? Worry no more, because the solution to your problem is here. Educative IO, as the name suggests, offers wide variety of courses taught by top tech industry professionals. They have wide range of courses from programming language, AI, cloud computing courses, and so much more. You just name it. Follow the link in my description and boost up your career today. Alrighty, so start off by looking at how you can set up LLAMA 3 on your local machine. So to do that, you have to go to Langchain LLAMA. So I'll make sure this link is in the description, so that you just click on it and it will take you right here. And over here you need to download LLAMA. Okay, so based on your operating system, you need to download LLAMA for either Windows, Mac, or even Linux. It supports any of the operating system. So right here you click on download, and this will open up the LLAMA website for you to download. So if it's Windows, you click on Windows and then you download it for Windows. If it's for Mac OS and Linux, you do the same thing. So right after downloading it, when you go to your downloads, you see it here. So this is LLAMA Setup, and then all you need to do is to click on it and install it. So after installing it, you can open your terminal and then you will see that LLAMA is running. So you have to just open it, and when you open your terminal, you will see LLAMA is running. Then the next thing to do is to download one of the open source models released by Meta AI or Meta. So it's pretty simple. You follow the same guide. You just need to come back here, and to download any of the model, for example, you can just do LLAMA pool. So you copy this command. In this tutorial, we'll be using LLAMA 3, and we'll also be using GPT-3 Turbo. So we'll be using two models, and I'll show you the reason for that. So you just paste in this. So let's say LLAMA pool LLAMA 3, which I've done it already. When you click on it, this will go ahead and then download LLAMA 3 on your local machine, and from here you can access LLAMA 3 across all your codes. So you just hit enter on this command, and this will just go ahead and pull the latest version of LLAMA for you. So you can see I've already pulled this, and it has just downloaded. It's about 4.7 gig, and that's it. So back here, after downloading it, so you can use LLAMA directly in your terminal, so because it's automatically saved on localhost at this particular port. And also you can use it via this API, or in Python using Langchain framework, you can use it accessing it this way. So we will be accessing it this way in our code. That's all you need to set up LLAMA on your local machine. So you can see we got a success message, and you can see it right here. You can download multiple versions like LLAMA 3, LLAMA 2, or any other LLAMA model you want to download. Then to also run it, you can run it right in your terminal. You do LLAMA run, then the name of the llama model you want to run. So in our case, LLAMA 3 latest, since that's the name. When you hit enter, you can now go ahead to run this. Alright, so you can see an instance of LLAMA 3 running, and over here you can even chat with it right in your terminal. So you can just tell it to tell me a story about AI. So let me even increase this, and then you can see. So when you hit enter, this will go ahead to write you a story about AI. I don't know, LLAMA 3 is very slow when you are using LLAMA to run it. I think you guys can come out with or figure out with much better and faster way of running it. So you can see it's taking a lot of time before it writes you the story. Okay, so that's basically how to set LLAMA on your local machine. Let's now get started. Okay, so let's go through the file systems we'll be using. So for this particular tutorial, this is our requirement.txt file, and this contains the libraries we need to install for this particular tutorial. So we'll be installing Crew AI, and after installing Crew AI, this will go ahead and install all the Langchain dependencies you need to build your project. So it's a single library that installs everything you need to build your project. Then we'll also be installing 5 CPU for our vector storage. So we'll do this vector storage locally, which will run on our machine. It's not going to send anything to the cloud. Everything will be running on our machine. Okay. Okay, so that's for the requirement.txt. Then the next thing is the data. Since you are going to build a chatbot, we need the data. So you need the data to build a chatbot so that the chatbot can answer questions based on that data by providing it with. So I have a very huge data here, and guys, I will not be sharing this data with you because this is a data from a company I've worked with. So I'm not allowed to share it with you. I'm only going to show you how you can use it to build your personalized chatbot. Okay, you can search for your own data, or based on your own use case, you provide your own much detailed data for building the chatbot. So you can see this interaction between the company's customer care and the customers. So it's a very huge data. When I scroll through it, you can see it's not something small, it's very huge amount of data. And this is going to make our chatbot very smarter because we have a lot of data that is going to answer customers from. Okay. So that is for the data aspect of it. Apart from that, what other thing you need is we'll be using OpenAI as well because LLAMA is running slowly, but I'll show you how to use it in the code if you prefer it, or you can just download the model directly on your local machine. Then you can use LLAMA without OpenAI. But for the tutorials, I'll use OpenAI to speed things up. So for that, you need your OpenAI API key. So you create .env file in your project directory, and all you need to do is to write OpenAI API key and paste your API key right here so that you can access it in the code. So that's all for the files we'll be using. That's all for everything. We can now go ahead and look at the flow diagram of what we are going to build. All right, so this is what we are going to be building. We'll build everything according to this flow diagram we are seeing here. So this diagram represents how our chatbot is going to function. So let's say you have this chatbot for your clothing company, and this is on your website, and a customer comes to ask a question: what is the price for a particular cloth or a particular shirt? First, what your system will do is that it will send that question to two places. First, it will send that question to your vector database containing this data I'm showing right here, and then it will search through this data to find out the price for that particular clothing. Then when it sees the pricing, it retrieves that particular information or that relevant chunk from your vector database and sends that relevant chunks to your large language model together with your question again. So you can see the question right here is coming to search for relevant chunks or relevant context from your vector database, and at the same time going to your large language model. So in the large language model, once the large language model gets your relevant chunk or your context, it will use your question and give you a response or answer based on your relevant information. Okay, so in this case, this large language model is not going to give answers out of nothing. It's not going to tell you what it doesn't know. It will answer your customers based on this data that you've provided it with. And that's the nice thing about LLM based chatbots. Okay, so the system we are trying to implement right here is called Retrieval Augmented Generation, RAG based system, and this is the new way for large language models. It works well for large language models. So this is how simple the system we are going to build is. You have question about the diagram, make sure you leave it in the description. I'll be very glad to help you out. Okay, so that's it. That's the flow diagram. So let's get right into coding and start to write some codes. the first thing I'll do is to create a file. I'll just create a IPython file or IPython notebook. For that, I'll call it chatbot.ipynd, which stands for IPython notebook. Hit enter on this, and this will load up and build up our kernel. I can now go ahead, close this app. Before you make sure you run any code, make sure you install everything in the requirement.txt file. So I'll do that with you. For that, just open your terminal, new terminal, and you have to write this command. So you have to write pip install, then you do -r, and the next thing you have to type is the name of your requirement file, which in our case requirement.txt. So that's all, and hit enter on this, and this is going to install all the necessary libraries you need for this particular tutorial. But guys, hear me out. Before you can use Crew AI, you have to make sure you are using Python 3.10. I tried it with other several versions of Python, and I was getting some weird errors. So make sure you are using Python version 3.10, and this is going to work out for you. Okay, but we got some error here. I didn't spell install correctly, so let me correct that. That should be install, and you enter on that. So in my case, I'm going to get requirement already satisfied because I went ahead and installed all these libraries before recording this tutorial. So in your case, you go ahead and install it. It will take some time based on your internet speed. All right, so installation is done. You can now close the terminal. You have to make sure we open our chatbot.ipython notebook. Then we can minimize this and start to code. So the first thing we'll do is to import all the necessary libraries we'll be using. So I'll just go ahead and paste them right here. And then as usual, as you are coding along, I'll be showing you what each and every import right is doing. There are a lot of imports, and if I should explain all of them right on the go, it wouldn't make much sense. But if you are coding along and I'm showing you what each import is doing, I think that make much sense and make it very easy for you to understand. So I'll run this cell. All I'll do is to select the kernel, and this will connect to that particular kernel and run this cell for me. Okay. Alrighty, so all our libraries are imported, and you can see we got the sources mark here. And the next thing I'll go ahead and do is to set up LLAMA. So I'll set up these two LLMs, both LLAMA and the GPT 3.5 Turbo. So I'll just say LLAMA LLM, and this will be equal to our LLAMA, and inside here we give it the model name as LLAMA3. We are creating an instance of LLAMA here because we can see we are importing it here. So from Langchain community.llms, we are importing LLAMA, and then we create an instance of LLAMA here. We are providing it with the particular LLAMA model we want to use. So we are able to do this because from the starting, I taught you how to set up LLAMA and also how to run it on your local machine. So in case you don't set it up, when you put up LLAMA right here, when you set an instance of it here and you run it, you get an error. So you have to make sure first you set it up using the LLAMA, and then you make sure it's running before you can access it right here in your code. Okay. So I told you to write me a story, and you can see it started writing the story, but I told you guys that it's very slow when you are running it with the LLAMA. So it started in the year 2050 dash and still trying to figure its way out about writing the story. But we'll continue our coding stuff. I will not wait for that story. So that's how you set up LLAMA, and then you can just go ahead to run this cell for setting it up, and this will set it up. So you can see we still got a success mark, and that means we have successfully set up LLAMA. Okay, so the next step is to set up the GPT we'll be using. Okay, so we'll load up the API key and make sure we provide that to GPT, and with that we can get access to the GPT model as well. I will first load the API key, so I'll just do load.env, and we are doing this because we have imported .env here. So from .env we are importing load.env. So I'll do load.env, and at the down here I'll just do my API key, and this is equal to os.getEnv. So right here you have to give it the name you've given to your API key in the .env file. So over there we've written the name as OpenAI API key. So I'll just type the exact name right here, OpenAI underscore API key. Okay, so this is the exact name we've typed there, and with this we'll be able to access our API key. I also go ahead and specify the type of model I'll be using. So GPT also have some varieties of model, GPT-4, GPT 3.5, and so on. But I told you guys we'll be using GPT 3.5 table, and this is the particular GPT model we'll be using. Okay, so right after that, what we can do is to now give this model name and the API key to the OpenAI model, and then it will be able to access the large language model. So I'll call this one to GPT underscore LLM, and this will be equal to our chat OpenAI. And inside here, all you need to give it is your API key and then your model. So API key. Okay, so this is all you need to set it up. GPT LLM, then we are using chat OpenAI because we have imported chat OpenAI right here. So you can see we have chat OpenAI, which we are importing from Langchain.chat models. So let me replace it here. And then inside this, we are giving it our API key, which is here. And we are also giving it the particular model we want to use. So I can quickly run this to see, and we've gotten the check mark. That means it's working. So to confirm this is working, we can invoke this model. So we go GPT LLM dot invoke. In here we can tell it to say something. So we can ask what is a bot. So GPT, okay, we have some typo here. What is the name I've given here? GPT LLM, and down here we are doing GTP. So I'll just correct this name here and run it once again. Okay, so this time around it will work, and you can see we got a response from the model. So this response is an AI message, which I will show you how to extract the exact content from this right now. The model we've set up is working perfectly, so we just have to go ahead and use this model to answer customer questions based on our data, and that's what our chatbot will be doing. Okay, but before we proceed, we have to fix this. You can see the response from our LLM is always an AI message, which we don't want. All we need is this content. So for that, we use the parser we are importing. So you can see from Langchain core output, we are importing string output parser, and we can use this to access only the response content, which is the content right here, the message content from our AI message. So I'll quickly set that up. I'll call this parser, and this will be equal to the string output parser. So with this, we can be able to chain our model with the parser together, and then this will be returning to us only the content. So for this, I'm going to create a GPT chain. So GPT chain, and over here, I'm chaining the GPT LLM and the parser together so that at the end of the day, I'll only get the content and not AI message, because we don't need some of these things, the total tokens, the model name. We don't need all of that. All we need is the response from the model. So I'll chain them together. So GPT LLM, and then I'll chain it together with the parser, and that's all Langchain is about. It's about chaining things together. So now we can invoke this once again to see the response. For that, I can just do GPT chain dot invoke, and I'll ask it the same question: what is a bot? And I expect to get only the content and not AI message. So let's try the same thing out. And you can see right here, we got the answer. A bot, short for robot, is a software. So this gives you only the answer and not AI message as we have gotten previously from here. Okay, so now we know our GPT is working. We know our LLAMA model is also working, but just that the LLAMA model takes a long time to run on our local machine. So I'll be focusing more on the GPT model. But in case you want to run it, you can also use it and invoke it the same way we are doing this one. So you can do LLAMA.invoke, and it's going to also give you response. For instance, if I should do it that right here, LLAMA LLM.invoke, and over here I can ask it what is a bot, and I can go ahead and run this. So this will also run and give me a response, but just that it's going to take a longer time. You can see it's still running and no output yet. Okay, so that's why I'll be focusing on the GPT. But if you want to use it, you can fairly use it in your code as well. It works just like a charm. It's perfect. The response from the LLAMA model is quite accurate and very good as well. But I'll be focusing on the GPT because of the speed issue we are having now. So it's still running and no response, so I'll just have to stop it. So now that we are done setting up our large language model, aka LLM, we will now go ahead and read in our data and save this data into our vector database. Okay, so for the diagram we are using, you can see data is saved in a vector database. We'll be using files, and then when you ask the question, it will go there to retrieve the relevant chunk. So we'll read in the data I showed you from the beginning, which is this data, and then we'll go ahead and save it into this vector database. Okay, so that's what we'll do next. And to do that, we've imported a text loader. So Langchain have different type of loaders. In my recent video, we have used the PyPDF loader. Today we'll be using the text loader to load our data, because the data we are having is a text data, or it's a textual data in a TXT file. So to do that, I will say my loader right here is equal to text loader, and in here you provide the path to the text you want to load. So the name is data.txt, and it's in the same path, so I can just specify the name. So this is the path to which your data is, and the name of my data file is just data.txt. Okay, so right after loading it, what we can do is that we can call them our document, or we can call it our document, and is equal to our loader.load. So this right here is going to load them as pages. Okay, so this will load all our data right here on different pages. So later on, we have to break these pages down into chunks, then we can store it in our vector database. So what I'll do is that I'll go ahead and run this, and this will take some time to run because we have a very huge amount of data. So we have to actually encode this. So we'll do the encoding is equal to UTF-8. Okay, so that's the encoding method we use, and I think this should work fine now after the encoding. Okay, so now we've loaded our data, and if I should do documents, we can get some sample of our pages. Okay, all right, so you can see we got some sample of our document, and it's quite long. It's a very big data, as I've showed you here already. It's very big, very huge data. So this is a sample of it right after loading it with our test loader. So now the next thing is to split this document into smaller chunks so that we can push it into the vector database. I'll show you this by using this diagram. So right here, after reading your document, you have to split this document into smaller chunks. So you can see before sending it into the vector store, so you split it into smaller chunks. Okay, the big document you've read into pages, you have to split it into smaller chunks, and then you create embeddings out of it and then push it to your vector database. Let's go ahead and split it, which is also very easy to do. So we'll specify our splitter, and this will be equal to our recursive character splitter. So we've imported that here, recursive character splitter from Langchain. So we'll just use it to split our document into smaller chunks. I'll paste it right here, and all this needs is your chunk size. So it will take the chunk size. What's the size of the chunks? So we'll provide that. Okay, so we specify the chunk size to be 200 and also overlap to be 50. So overlap is like let me open this up. Let's say your first chunk starts and end here. Without overlap, your second chunk will start from here, but with overlap, your second chunk will contain some of the data belonging to your first chunk. So let's say your second chunk can also start from here, having some data or sense of data from your first chunk, and this improves how your chatbot works drastically. Okay, so that's what overlap means, and we'll specify it to be 50. Okay, so right here, what we'll do is that we'll now get our pages, and we'll say our pages is equal to our splitter dot split underscore documents. So in here, you just have to provide your document which you have read at the top. So over here, we've read our document, and then we are passing in this document to our splitter so that it will split them into smaller pages or smaller chunks. So we can just call these chunks instead of pages. Okay, so this is it, and we can now run this, or we can run this for it to load all our documents into smaller chunks. Okay, so right here it has loaded it into smaller chunk, and we can access some of these chunks by just writing maybe chunks, and it's a list, so we can access maybe the first three of it. I'm rerunning the whole thing once again. I should have done it under a new line, which would have been faster. So you can see, so this will retrieve the first three chunk for you, and here is it. So this is the first three. You can specify any amount at all. Okay, so now we've splitted our data into chunks. We are about to push it into the vector database. Before we push it to the vector database, we have to convert it to embeddings. So embeddings is like numerical representation of our data. So it's like vectors. Okay, so we are going to convert this right into embeddings before we send it into the vector database, and this is very easy to do because we are importing OpenAI embeddings right here. So from OpenAI embeddings, we are importing OpenAI embeddings, and we'll use these to embed it and send it to our vector database. So to do that, we just come down here, and we need only these lines of code. So we call it our vector storage is the files, and we have imported this and dot from document, and over here all you need to do is to send it to your chunks. So we'll give it our chunks, and we are saying, okay, we are converting these chunks to embeddings. Then after that, we are creating a retriever from our vector storage. Okay, so we can use this retriever to retrieve specific chunk that relates to some specific information. So let's run this, and this will go ahead and convert all these our chunks into embeddings, which will be embedded into our vector storage. So this will take some time because our data is huge, and this is going to take some time to convert all this data into embeddings. And this is the reason why I like using IPython notebook or Jupyter notebook. If we should use a normal maybe main.py file, this will run over and over. Anytime you run the code, this will take the same time, which is time wasting or time consuming. So it's better you do it like this, and then it loaded it into memory once and for all, and then you can continue to use it until you disconnect your runtime. Okay, so now we've successfully converted all our chunks into embeddings, and this is stored in our vector database. So the brilliant thing is that now that we've created the retriever, we can right from here use this retriever to retrieve specific chunks about any question we ask. So we can just do retriever.invoke, just as we've invoking our model, and right here we can ask it a question. So I can ask it what is the pricing for Be Human. That's the company, so you guys can check it out. So what's the pricing for Be Human? And I know in this big information, or in this big data, it will surely have information about that. So I'll quickly run this, and this should retrieve the first four chunks of data that contains this information. So you can see that right here. So this will retrieve the first four similar chunks of data that contains the information about the question I'm retrieving, and this is the information the LLM is going to use to answer your customers. Okay guys, so the retriever will go ahead and retrieve the pages that contains the context of the question you are having, and based on that information, or based on these pages, our LLM will now go ahead to answer our customers. Okay, so that's what the retriever is doing, and you can ask for more chunks. For now I'm just taking the first four. By default it gives you the first four, but you can even take the first two. It's just in the list, so you can take the first two, you can take any number you want. Okay, so that's just a bit of information I'm trying to give you. So that's the brilliant thing about our retriever, which we can use it directly to retrieve pages that contains some important information. So you can see it has even retrieved a link giving us link to BH Human AI pricing, and when you click this link, this will take you to their platform for you to even know the pricing or the updated pricing for their company. So that's for the retriever. And now that we've set up the retriever, we are almost done. We can now come out with our prompt template to instruct this LLM on what to do. So we set up a prompt template, and I'll just paste that and explain it to you because it's pretty much simple, and we have done that in our previous tutorial as well. So I'll create a template, and this is the template that controls your LLM on how to answer your customers. So we are telling this LLM that, okay, you are AI powered chatbot designed to provide information assistance for customers based on the context provided to you only. So the context you are providing will be the information from the retriever, and we are telling this LLM that you should answer these customers based on this information only. It shouldn't make things up because the LLM by default doesn't know about my company. It doesn't know anything about my company. Maybe it will know, but I'm sure it doesn't know anything about my company. So it should use only the information I'm giving it to answer my customers, and that's what we are trying to do. So that's the template we are creating, and we can now create a prompt template out of this template to work with it. Okay, so I've imported a prompt template at the top here. So at the top here from Langchain.template, you can see we are importing prompt template, and we can go ahead and use it right here with the template we've created. So prompt is equal to prompt template from template, and then you give it the template you've created, and this template is what is going to instruct the LLM or the chatbot on how to answer our customers. So we give it our template, and then we are telling it, okay, this is the context, use it to answer the question, and we also give it the question. So it is going to, this prompt template will take a question and a context. So you can see them right here. It takes a context, and the context is coming from our retriever, and the question is coming from our user. So our users, our customers on our site, that's where the question is coming from. Okay. So we use that to create a prompt template, and we'll use this prompt template to instruct our large language model. Okay. So before we create the final step, let me show you this right here. So you can see the question we are taking from our user is going to two places. We'll first go to the LLM and also go to our vector database to do a similarity search. So when you ask it a question, to just find out the chunks in our database that relate to that particular question, just as we are using the retriever to do right here. So we asked it a question about pricing. It has retrieved the document having that question, and our LLM will go ahead and answer us based on that document. So to do that, you can see right that our question is going to two places. So this is like a closed loop system. So what we need to do is to use a runnable pass-through and a runnable parallel to run all of this in a parallel, and Langchain provide you with that automatically. So I'll just bring that in, and then we can just use that to run everything and chain everything together. Okay, so we are importing the runnable parallel and the runnable pass-through at the top. Let me quickly show you. So you can see them from Langchain.core runnables. You are importing runnable pass-through and runnable parallel, and that's what we are going to use to run everything together. So we have runnable parallel here, and this will take the context. So this context is coming from where? Our retriever. Guys, just check this out from the diagram. The context comes from where? Our retriever. The retriever will come into the vector database and retrieve the document that are related to the question asked by the user, and still send this same question to our LLM to answer the user based on the relevant chunk. Okay, so that's what we are doing. We are getting the context from our retriever, and then the question, we are running this question as a runnable pass through, because this question is not only going to pass through our vector database, but it will also pass through our LLM. So you can see the question goes this way and also goes this way. So we are running it as a runnable pass through so that it will go through both the LLM and also our vector database. So that's what our runnable pass through and the runnable parallel is doing. Parallel will just allow us to run everything in parallel. Then right after that, we are chaining everything together. I told you from the beginning about the long chain effect. You chain your result you are getting from this together with the prompt template, together with your LLM and your parser. So the parser will make sure we are getting only string output and not AI message. Okay, so I'll give this a run, and that's done. So Right from here now, our chatbot is ready, and this chatbot can now begin to answer questions based on whatever we are doing. So I'll just paste this here. We use the chain.invoke, and I'll ask it the same question: what's the pricing plan for BH human? And I'll run this. So what it will do in the background is that it will perform this same retriever stuff. That the retriever will find this document, and it will send this document to our large language model for it to answer us. So that's what is performing at the background, and here we go. So you can see the answer. The pricing plan for BH human includes a paid plan which can only be cloned with the paid plan. However, there is a 7-day free trial available, and you can cancel your subscription at any time. More information about pricing can be found here. Guys, this is just amazing. So imagine your chatbot answering or serving your users like this on your site. You have no much work to do with customer service. Okay, let the chatbot handle it for you. We are in 2024. We are in the year of large language models, and these language models are doing amazing stuff, guys. So just look at this. Additionally, there are different plans available, such as the growth plan for $39 per month, which is recommended for startups. So it gives you much information, and that this works. Okay, this is just good. So let's ask it another question. I'll paste this right here, and I'll say what is maybe BH human. Yeah, let's just ask what is BH human. So let's say a customer comes to your site. It doesn't know what you do, so it's asking your bot on your site about your company. So let's see the answer it will give us. Okay, so you can see this is brilliant. Be Human is a platform that allows you to personalize videos at scale by cloning the face and voice of person in the video. It is incredible tool for engage. So guys, this is just good. What I like about it is that it gives you link to read articles. So which other question can I ask? Since they are into personalized video producing, I can just ask, okay, my video is not clear, so I'm using their service, and I say, okay, my video is not clear. Let's see what the bot will tell me. Will it give me an answer, or it will not give me any answer? Okay, so based on the context provided, it seems like you may be experiencing issues with the clarity of your video. Yes, that's what I'm experiencing as a customer. Then one suggestion mentioned in the document is to adjust the lighting for better visibility. Guys, this is very good. So this is a brilliant answer, and this answer is coming right from our data we've provided this chatbot with. Try using low lighting instead of bright, well lit lighting to make it easy to see your map and improve the clarity of. So this is just great. If it even directs you, if you need more detailed suggestion, feel free to reach out for further assistance. This is what bots should do, and this is what our bot is doing right here. If this is not amazing to you guys, then I don't know what else will amaze you. And this just simple. With only few lines of code, we are able to create our personalized chatbot that answers questions on our data. So guys, this is how easy it is to create your own chatbot from your data. So provided you are having a data, you can create your own chatbot, and you can run this with the open source llama models for free instead of using the GPT. I'm just using the GPT because of the speed issues, and I can't afford to download the whole llama model with 8 billion parameters on my machine. So that's why I'm using the GPT. The llama I'm using through LLAMA is very slow, and I can't use it for this tutorial, but it works. When you sit down and wait for it, it gives you response. So guys, this is all for this tutorial. If you have any questions, you have any doubts, just put it in the comment section for me. You need help concerning anything I've said in this tutorial, just let me know. And for those of you folks out there that are ahead of me, I don't know it all, make sure you put me on the right track if you think there is something I should add and I didn't do that. Thanks for watching once again, and I'll see you in the next tutorial.